So here we have Alex, and Alex will talk about will AI finally replace the developers? So we have a theme going on here, don't we? Now more about Alex is Alex is the head of machine learning and DevOps at Zencoder, and Zencoder is the next generation AI agent that automates tasks, enhances collaboration, and improves your code quality. And during the breaks, feel free to chat with Alex about Python, TensorFlow, PyTorch, ABS. He's considered an expert in all of these. He has also worked across many different domains, from image and video processing to bioinformatics, so I'm sure you can find some connections there. But I think I will get give a word to Alex now. Enjoy the talk and have fun.
Alright, hello everyone. 1 second, let me set this whole thing up. Right, here. Perfect. Let's see if this works. Yeah. Alright. Hello everyone. Yeah. Thanks for the introduction. My name is Alex. I will be talking about the future of AI, or rather past, present, and future. I think it's a good continuation of the previous talk, which kinda already touched upon some of the points which I will be making throughout my talk. And a few other sort of fun facts about me. I've been working in IT for more than 10 years now, mostly in AI and ML space, also DevOps, MLOps, so all different fields. I've been building Zencoder, what we now position as a universal AI platform from day zero, and I will talk briefly about what we mean by universal AI platform in the end of the slides. I've also been, for the past year, mostly DevRel, jumping between conferences, which kind of results in a lot of flights. So my flight here to Dublin was actually the flight number 18, so yay, I guess. And I have 4 cats, which are waiting for me back in Portugal. Alright, and another fun fact, so I was accepted to this conference actually almost 10 months ago, February 12th, and I actually left how the numbers come into the whole sequence, 1, 2, 3, 4, 5, and actually if you convert the day of the week and the month, the numbers actually will be 3 to 1, anyway. So I was accepted to this conference 10 months ago, and at that time, I mean, given the time of my talk, I honestly wasn't sure how it will look like today, right? Because obviously in the world of AI, things move quite quickly. The progress is staggering. So one month in AI space is kind of like a year in outside the world. And AI, what could happen? What could go wrong, right? So back in February, I wasn't even sure if we will be all there. I mean, talking of course, but we are still here. So actually, for this presentation, I decided to take a look back at the past 10 months and build a quick timeline on which models have been released since the day of acceptance of my talk to this presentation. And who remembers which models you were able to use back in February, back in January this year? So which model from Anthropic or OpenAI you could use back then?
Like Cloud Code was what? Sonnet 3.7.
Okay.
And then GPT 03 was already there. I don't know.
Yeah, quite close. So the answer was GPT, the answer was Cloud 3.7 and GPT 03 on the 4. They came out at the same day. But actually, the correct answer is at the beginning of the year, it was on 3.5 and GPT-4, and we went through several generations, pretty much of both Anthropics and GPT models. Right, so we had Sonnet 3.7, we had GPT-4.5, we had GPT-03, we had Sonnet 4. Just a couple of days ago, we had Sonnet 4.5, and GPT-5 was out in August. So in a matter of just 10 months, we went through 3-4 generations of models. And if you remember, by the way, the numbers here, the percentage is the performance of the models on the data set related to coding, a SV bench. And if you remember how good, or I should say how bad, the code was back in January and February, and how it is now, you probably can see the difference, right? So in terms of quality and capabilities of the models in just a short span of 10 years. Oh, sorry, 10 months, not years. And well, you can imagine what will potentially happen in the next couple of years if that progression keeps on going, right? So yeah, and well, actually, of course, also asked if they can think that if AI will replace developers. Of course, it's a no, but you know, it's AI, so it sometimes makes mistakes. So not everybody is trusted, but at the same time, you might have seen a lot of headlines like this. So in this case, Mark Zuckerberg back in January said that AI will replace developers by 2030, I believe. And again, this is January 26th, so it was back at Cloud 3.5 and GPT-4o, which obviously were quite a step back compared to our current generation of models. And even then, people already started talking about AI replacing developers, whatnot, even though, you know, given this kind of predictions is always not the most prolific thing to do, right? Because, of course, they not always come to fruition, and even people like Elon Musk or Jeffrey Hinton gave a lot of predictions which didn't come to real life. But at the same time, I think that self-driving cars are a good analogy of what is going in with AI in our world in software development. And for those who are not familiar with self-driving cars, they have several levels of autonomy, right? So they have 6 levels, or 5 if you exclude no automation whatsoever, and they basically progressively increase the autonomy of the cars, starting from level 1, where it is just a simple help to the driver, like maybe cruise control, speed control, whatever, and all the way to the full automation, where the person behind the wheel, even if there is even a wheel, doesn't drive at all, right? The car does all things on its own, in any conditions, in any time of the day, time of the year. Basically, the car can drive itself on every road. And as you might have noticed, this image was generated by, I think it was backed by GPT-4.5. So GPT-4.5 didn't know how to center the images, which is kind of making it, I guess, a backend developer in a sense, right? But yeah, so I like this analogy of self-driving car levels, because I think it quite nicely can be aligned to our software development world and how AI is changing, right? So if we start with level 1, it is essentially when Copilot first came out, which was just 4 years ago, right? And it essentially was just an L1 wrapper and nothing more. It was able to use some code conditions, so essentially it was like a text prediction on steroids. And sometimes it didn't work as expected, right? So, for example, it couldn't send some patterns, but it wasn't able to actually understand what those patterns mean in physical world, right? But then we also all know how AI is good at hands, so it's not surprising. Then, at some point, we started to feed into the LLM some new feedback, right? So we went to level 2, which we were currently living in for the last couple years. So we started to feed in things like syntax feedback, right? So when you use your IDE, like VS Code or JetBrains, you get some sort of highlighting when there is some errors in the code, there is some error in the syntax. So we could feed this into the AI back in response on the generated code, and it could then act on this, fix some issues, and so on, and hopefully give us a bit better code, right? You could, of course, also generate a bunch of code through the LLM and then spend some time debugging it. But yeah, it tried to be helpful. In some cases it was, in some cases it wasn't. And the reason for that, as actually was also mentioned by previous speakers, is that LLM, they first of all are undeterministic in nature, and they also are trained to predict the next most probable token, most probable symbol, and sometimes this can lead to errors, right? So especially if you are using some sort of library, some sort of framework which you develop in your own company, LLM has no knowledge about it. It has no knowledge about infrastructure, about your code base. So essentially, it will just default to sort of open source framework, the most popular framework in the dataset, in open source data, and completely discard your own frameworks, your own internal frameworks, and so on. Then this year we went into what is called AI agents, right? So and here called junior software agents. And at this stage, we started to get some sort of more advanced feedback into the model, right? So we were able to connect the LLMs to environment. And by environment, I mean like the development environment. We were able to connect it to some resources, some remote resources, whatnot. And this allowed LLM to not just simply generate a code, it allowed also to, for example, compile it, right? It allowed to run the tests, it allowed to run the code on the actual environment where it is supposed to run. And then, based on the outcome of that, it was able to act accordingly, right? So if the code generated by LLM didn't compile, produced some errors, the LLM was able to detect those errors and fix the code, hopefully, right? Or try to fix at least, then maybe run again, compile again, and then go this in a loop until hopefully it succeeds. And this advancement is enabled by what is called AI agents. And we can define AI agent essentially as a software that is performing tasks on your behalf, on behalf of the user. Also, this definition sounds pretty much like any software, right? So any software is performing tasks on your behalf. So what's the difference? The difference is that AI agents follow the following design pattern or principles, which distinguishes them from just regular LLM, from just regular software, and also allows them to be much more powerful and much more accurate in their predictions. So first, they can use tools, right? So I already mentioned compiling, I already mentioned running code. So all of that are essentially enabled by tool use, where you can give LLM access to your local file system, to Bash, to GitHub, to Jira, whatnot, and then LLM can use those tools to gather more context, to run some commands, to search for something and so on, and use that to gather more context and act and iterate on its own work. And this also goes into reflection, where LLMs or agents can essentially don't just create something, they don't just treat output, they can also reflect on its work, they can reflect on the outcome of its work. So again, they can try to compile and then act based on those errors from the compilation and reflect and see what's going on and maybe fix the issues, right? They can also plan. So if you used recently, for the last half a year, ChatGPT or Claude Desktop, for example, or other code generation tools, you've probably seen those thinking process where LLM essentially is thinking or planning its own steps, it's thinking about the task, it's thinking what it needs to do, and so on. So essentially it is sort of like a voice in our head, which is helping us to plan ahead, hopefully, right? Which can also advance LLM's capabilities further, because it essentially creates for itself, it can create for itself a step-by-step plan and then act based on this plan. And then of course, each agent can collaborate with other agent, so we go into the multi-agent collaboration. So you might have one agent working on code generation, another agent working on validation of code, and so on. And together, they either work together or against each other to give you better results. And we can see how this affects the capabilities of the model on here on this diagram, for example. So this one is from GPT-5. And you can see how much boost just simple two things like playing, like thinking, and tools, in this case Python web search, can give to LLM, right? So the model itself, the vanilla LLM, on this data set can only get 6.3% of results. But if you let it think, or essentially do the playing, and let it use Python and web search, it boosts the result all the way to 35%, and for larger models it gets to 42%. So essentially, already just a few problems, right? Playing and a couple tools can significantly improve the capabilities, the quality of results, and so on. And then we transform this flow into our work. And coincidentally, I also used the sort of Figma code example. It wasn't pre-planned, so I guess it's a popular application of AI nowadays. But yeah, if we take this sort of Figma code example, right? So in this case, the task would be to update the code based on Figma updates. The flow would be something like that. Right? So first, the agent would use the tools to get the designs, to get the changes. Then it needs to do some planning, of course, right? To understand which files it needs to modify, which kind of changes it needs to do, and so on. Then it might use other tools to, for example, run the website, get some screenshots, compare it to the Figma. So we go to the selection step, right? And then it can basically repeat this over and over until it is satisfied with the results. It might also decide to run some end-to-end tests, for example, and which is another, again, tool, right? So it could be playwright tests, could be some curl commands, whatnot. But essentially it will be another case of tool use, another case of playing and reflection. And this loop sort of goes over and over until the LLM is satisfied with the result. And hopefully you, as a user, also is satisfied with the result. And well, this sort of slowly went on in the beginning of the year until we moved into more advanced space, where we started to have not just single agent working on our behalf, but sort of swarm of agents or multiple agents working together in a different fashion, right? And we currently are somewhere between level 3 and level 4, I would say. So at level 4, we start to get more, or not we, LLM, start to get more verification, more input from other systems. So it could be some end-to-end tests, where again, like in the example with Figma, it would run the browser, run the website, click around on the website, generate tests for that, then use this as a verification step. Could be some other agents working together or against each other, give some feedback, give some, provide some examples and whatnot. So essentially, if we look back at this example with Figma, at level 4, we are now not at the level of user and agent, we are at the level of user and multiple agents. And those agents can interact with each other in different fashions. So it could be some supervisor schema, it could be some hierarchy, it could be some random swarm of agents, like on this example here. So essentially, you take all those agents and you put them to the task, and they hopefully come up with something meaningful. And actually, in the background, before I started the talk, I started my own multi-agent system, the single task, and let's see if they actually finished. We switch to Teams tab over here. Alright, so I think they finished. So I will share the link to this code in a second, but basically what I have here is a multi-agent system which consists of 5 agents. So there is a product manager, which is tasked to do the planning and then assign the work to different agents. And there is also backend, front-end, DevOps, and QA agents, which are responsible for their own sort of part of the team's responsibilities, right? So backend, of course, is responsible for backend and so on. And the prompts are quite simple. Nothing fancy here, and you can also, of course, as I said, you'll be able to play with it on your own spare time. And the task for them was to build a website for the conference. It should have 10 pages. It should use pretty standard stack, right? So fast API, React for the front end, Docker, Postgres, nothing fancy about it. And yeah, that's pretty much it. And over here, let me unscroll this. So they went on to work. So the starting point was product manager, which essentially started with the first step of its plan, which was the backend. It transferred to the backend agent. Let me zoom in a bit. Here. So it transferred to the backend agent. Backend agent did some work, did a lot of work, a lot of code. So it's actually quite a lot of text here, as you can see on the scroll over here. It's quite a lot of text. Fastened up. So at some point, front-end agent started doing something else, right? It started working on the front-end. So it started implementing some JavaScript code for us. Let me scroll a bit further down. At some point, I would expect DevOps engineer, a DevOps agent, come in and start doing something for us. Let's see, still front-end. Alright, so this should be, I'm assuming, DevOps agent, right? So basically, step 3 of the product manager plan was to set up Docker Compose, which is, in this case, was assigned to the DevOps agent, which it did. Let's see, I think at some point it should give us a link. Hopefully, some schemas, whatnot. DevOps, alright. Okay, it pulled some images. And as I said, it's a lot of text. So I see the link over here. I think that's for the backend, usually, the 8,000. Let's see, the front-end part is on the port 3000. So let me actually go to localhost 3000. See if it actually works. Yeah, so there you go. So they essentially built this while I was talking about AI replacing us. So they built this whole thing. And actually, what's more, I didn't scroll all the way down. If you remember, I also have QA agent. So at some point it should have come in as well. I think that's the work of still DevOps. There's QA. So at some point QA came in as well, and it started testing the website. It started testing the application. So it started, in this case, I guess it started with some API tests, right? So it was using some curl commands. Actually, we should be able to see Joe's submitted talks somewhere over here. Yeah, so those talks were submitted by QA agent while it was testing the website, while it was testing the API. And yeah, so essentially quite a lot of tests. And then let's go back here. So we tested the backend. I think at some point, at some point it also decided to test the front-end part. So as you can see, it was able to navigate to the localhost. It started to enable JavaScript. Okay, so I'm not sure if it was able to actually test all the buttons and whatnot. But yeah, it was basically at least was able to test the backend in this case. Did quite a lot of tests, I would say. Still, yeah, so I tried to also navigate the browser, and this seems it worked at the second attempt. So it was able to essentially open the browser, click around, verify that all the buttons, all the directs are working, and then in the end, the product manager gave us, well, all these emoji, typical plot sonnet for 4.5 emojis with all the summaries, what has been done, all the setup, all the links, all the tests, all the commands, the schema, so well, basically everything, right? And all of this took maybe 10-15 minutes. Again, while I was talking about AI, they were running in the background and they created this website, fully working. Obviously not the best design probably, but it's still kind of looking around nice. Obviously it works, and they were also able to test it and find that everything working. And essentially it took them 10 minutes, 15 minutes to cover for the whole team, for the whole cross-functional team, just by me prompting a few. There's my notebook. Just by me, scroll all the way up, prompting a few agents. So each agent was 8 lines of prompt, and they were able to produce this fully working application. All right. So, and yeah, here's the code. Here's the link to the code itself, to the repository. If you want to play around with it, there are a few other notebooks there as well. So if you want to play around multi-agent systems, if you want to see how you can create your own systems, feel free to check it out. But if you don't want to spend time on developing this from scratch, of course, there are solutions which are already available. So previous speakers mentioned Cloud Code, and they also have what's called sub-agents, which is actually to some extent a multi-agent system already in their starting point. There is still a lot to go for Cloud Code to be truly multi-agentic system, but sub-agents is a good start. But then Cloud Code is a CLI tool, and if you want to use the same but in UI, you can try Zencoder. So as I mentioned at the beginning, Zencoder is what we call universal AI coding platform. And what we mean by this is that you are able to integrate into the entire plugin, which is available for Git code and Kubernetes. You can integrate all the things which you can get from Cloud Code, from OpenAI codecs, from Gemini CLI, so basically from all those terminal interface tools. You can use them inside your IDE. And on top of that, you can also get a lot of features from typical code assistant, which you could get from Cursor or Windsor with an SUI and whatnot. And you don't need to switch your IDE to use, again, Cloud Code or other features right inside your IDE. Now, all of this is nice, but we are kind of going to the direction of autonomous agents, which is level 5, right? And this is also where we can help you to migrate there. So what we have is, let me put back the slideshow. So what we have is what we call custom agents, which you can define on your own. And of course you can use some ID, similar to what I had in my Jupyter notebook. But what is more important, you can use those same custom agents you define for some specific tasks. You can use them to automate different tasks of your own. So for example, over here, I have my Jira. I know that nobody loves Jira, but well, we are still, we have to use it. And what I have set up in my Jira project is, once I label this ticket, or any ticket for the matter, once I label it with a specific label, in this case, an agents, this essentially triggers in the background multiple agents to work on this task. And I can switch to my GitHub over here. Let me reload the page. And as you can see, I just triggered this agent running in the background, solving the ticket for me. But of course, well, we won't be waiting for it to finish. I have a pull request from the previous round for the same ticket. So it was able to create a pull request for us. It was able to, first of all, of course, implement the ticket as well. So it did some changes over here. But then, on top of that, we have another custom agent which can do the pull request review. And let me scroll down. So this custom agent came in and started doing the pull request review. Found some issue, commented it, and then you can of course have another agent come in, address those questions, address the comments, and so on. So essentially you can put into your CI fully autonomous multi-agent system, which is, well, in this case can solve tickets for you, but essentially it can automate a lot of your mundane tasks. This is a good big segue and yeah, so basically when you have all the AI doing the code review and the code itself for you, it kind of reminds me of this picture. But yeah, so this kind of pushes us into level 5, which is full autonomy, right? So at this stage, agents would be able to not just generate code, not just verify that it works, but also would be able to, for example, talk with the customers, talk with the clients, get their feedback, analyze their feedback, compile it, and act on that. And essentially, it would be a fully autonomous systems, which would be able to do the work for us, right? So it's much like with the website. They didn't need to do anything. They didn't ask me for anything, although they could. So they had a tool to ask me as well, but they didn't They didn't need to ask me anything. They just had a task, which it was like 5 lines of text, and they were able to act based on this and create for me the fully working application. And well, as I've shown in the beginning, doing predictions is not the most, it's not the best job in the world, right? Because a lot of predictions are usually not coming to real world, at least on the dates which were predicted. But I still decided to put a date over here, so you can see in my case I put 2026, 2027, which is right around the corner, right? Which kind of begs the question. So the developers have 2 years left, and there are different opinions about this. And previous speakers also talked about what they think AI will do to us in the future, right? What it will do to software development in the future. And you might have heard the phrase that AI won't replace developers, but developers who use AI will replace developers. And I think it's a good sort of exaggeration of this phrase. But there is still some truth to that, although of course you can just blindly outsource all of the work to AI, because you still need to understand what's going on. At least for now, until AI is fully aware of its surroundings. You still need to be able to know what's going on. You still need to be able to debug when something is going wrong, and AI is still not at the stage where it can fully automate all the tasks. Again, as I said, we are somewhere between level 3 and level 4 in terms of sort of levels of autonomy. But seriously, if you go back to this autonomy level thing, if you try to apply the same principles, the same levels to software development, right? So when we think about self-driving cars, of course there are some jobs which will disappear, which will vanish, right? So taxi drivers, the first thing that comes to mind, right? So if all the cars can drive on its own, they can bring you to any place. Well, we don't need drivers, we don't need taxi drivers, so this job will be eliminated essentially at some point, right? But at the same time, these self-driving cars, first of all, they open a lot of new possibilities for new jobs, right? So there are some car mechanics which obviously would be needed for this. There are some new technology which is needed for self-driving cars, like lidars, radars, and whatnot, which needs to be maintained, which needs to be developed. So all this also opens up a huge set of new jobs and possibilities. But also for you as a car user, it also brings a lot of new things to enjoy while you're having a drive, right? So you're not focused anymore on driving, and you can spend that time on reading books, working, talking with your family and whatnot. Essentially outsourcing these mundane tasks of driving, and obviously people still like driving and I'm fine with them, but at the same time, obviously when you have to take a long drive, it kind of prohibits you from doing something else, right? You can't work and drive at the same time. And the same is true for essentially for coding, right? So I think AI don't eliminate software development, it would rather transform it into more of a tool, right? Where we won't be needing to write a code. We will be more of managers or reviewers of analytical pages, and we ourselves would be able to focus on more creative, more high-level tasks, pretty much like the self-driving cars. We won't need to drive, but we still would be able to use the product of driving, right? And the same with the development. We won't need to write the code, but we will still be able to first use the results of the development, but also we would be able to instead focus on more creative tasks, and we would also become more of a single person team, right? So as shown in my example, I had 4 engines, like backend, frontend, DevOps, and QA. So essentially, I as a single person was able to sort of command agents across multiple functions inside the cross-functional team. So a single person would become more of pretty much more of a cross-functional team of one person. And this obviously, of course, increases the capabilities of the whole company and the whole team in general. If all the people inside the team are like this, like cross-functional team in a single person. But of course, if AI still replaces all of us all, there is still one job left, which basically requires you to write code still, because AI needs a lot of data to train on. So somebody needs to produce the data. So of course, this job is still, at least for now, it is still safe. But that's all from my side. So if you want to try Zencoder, if you want to learn more about Zencoder, I will be here at the conference. So, but yeah, feel free to scan this QR code to get to the Zencoder website. And if you want to connect, if you still have some questions, I will those on Discord. But if you want to connect, this one is from our LinkedIn. So feel free to scan it and feel free to send me the connect request. I think I'm not sure what's going on. All right. Yeah, thank you all for attention, and if there are any questions, we'll be happy to answer them.
There is one question, although the break is supposed to start. I'll do this one question if it's okay with you all. Why is Zencoder not as generally well known as a tool like Cursor or Copilot or Cloud Code? Is it? What's your opinion?
Great question. So we started later than Cursor and Copilot, so we've been on the market less than a year. Right? So we're still a new company, we're still a new tool. At the same time, I see people moving from Cursor, moving from Copilot to us. And yeah, that's, I would say, the main reason. We are just kind of recently started, and I'm one of the persons who is kind of spreading the word about us. Yeah, that's, I would say, the main reason.
Good answer. Yeah, but thank you so much. If you have any more questions, ask them either on Discord and Alex can answer, or he'll be around. You probably can find him easily, so just ask face to face. Yes, thank you so much.
Thank you.
Thank you. Now, we are actually going on a little coffee break, a well-deserved coffee